going to talk about learning target 6A. And this is like the second to last day of doing this learning target. So I realize that this is like a long set of lessons to get through one learning target, but there's just a lot to do. So that's that. Let's talk about some stuff from yesterday or Tuesday. So Tuesday's lesson was about simplifying radical expressions, finding things that have exponents that match the index of the radical. So like finding something where there's something to the fourth in that one, or finding something that has a something to the fifth right here. So those are examples of things that we're going to be doing today also. So let's just talk about this really quick. Here's what I know. I know that 16 is 4 times 4, which means that that's 2 times 2 times 2 times 2. So that's 2 to the 4th. A to the 9th is a to the 8th times a. And I know that because of the exponent properties we talked about on Monday during our live lesson. B to the 16th is b to the 4th to the 4th. Remember, powers to powers, you can multiply those exponents. Okay, we're almost there. A to the 8th is a to the 2nd to the 4th, because that's a power to a power, and you can multiply those exponents. So you can get a little creative with this, and then come up with all these different things that have radicals or exponents that are 4s. So all of these things still have that 4th root over them. 2 to the 4th goes here. I still have an a, and then I have a b to the 4th to the 4th. Okay, now everything that has that 4 exponent that matches the index, I can take out of the radical. And what do I get here then? I get a 2 on the outside, I get an a squared, and then I get a b to the 4th. What am I left with on the inside of the radical? Well, everything else, which is just an a here. Okay. Normally, I would be like, hey, you know what? This is an even radical. The index is even. It's a 4. And so I need to think about absolute values. I need to think about, well, do I need an absolute value to reflect the fact that I should be getting a positive answer out? Because, for example, if you put in a negative number for b and you raise it to the 16th power, you're going to get a positive answer out. But I would here too, because it's a b to the 4th. And so if you raise a -1 to the 4th power, that also gives you a positive number. So your answer here, it doesn't matter if you need absolute value here or not, because either way, these two things are going to be positive. The one thing that we do need to pay attention to is the fact that there's an a left over here. And that means, well, if you put in a negative number here, you can't get a 4th root of a negative number. And so we have to restrict what's called the domain. And we have to say a has to be greater than or equal to 0. And that would have been true up here also. A is greater than or equal to 0. You can't put in negative numbers in for a and get something out for the whole thing. Okay. Let's do the other one. Immediately, I have some alarm bells going off because I have a 5 here, which means I'm looking for things that have exponents that are 5s inside the radical. And that's like, that's like annoying. And plus 224 is one of those numbers that I'm just like, I don't even know anything about that number. So we just have to start splitting it up. We have to be like, okay, you know what? 224 is 2 times 112. Because that's just what it is. 112 is, well, 2 times 56. 56 is, well, 2 times 28. 28 is, well, 2 times 14. And then 2 times 7 is what 14 is. And all of a sudden, I have that right here is 2 to the 5th. By the way, you could just be like, okay, these are all negative. So that's where I would go with that. I would start breaking it up. I would just be looking for how can I make factors of 224 work for me? What am I looking for? I'm looking for something to the fifth. So I need to just start breaking it apart and see what I see. Okay. It's not like there's a great set of strategies that I can give you about working with these big numbers like this, but really it's just how do you factor it out? How do you break it up to get to exponents that are fives? So now let's go back to the top here. We now know that we have the fifth root of -2 to the fifth times 7. That's what 224 is. Then we have our x to the 10th, which could be x to the second to the fifth. We have our y to the 15th, which is a y to the third to the fifth. And then that z to the 9th is not so nice, but we can write z to the fifth, z to the fourth. Remember that you can split it up like that because those two, you can add those exponents because it's the like bases, so you add those exponents. Okay, now pull everything out that has a exponent that's a 5 and leave everything else in. Since the radical is an odd index, you don't have to have any absolute values here. So you just get -2 x squared y cubed and a z on the outside. And then on the inside, you just have a 7 and a z to the fourth. And there's your answer. Okay, so that's a little review of what we did on Tuesday, and I realize that like that's a fair amount of time to spend on our review from Tuesday, but it's also good because you're going to be doing this not only on the assessment on Monday, by the way, but also you're going to need this skill for today. So it's useful for us to talk about it. Okay, good. Let's do a little multiplying with some radicals. Okay, so if you have a like index, you can multiply the stuff inside the radical. That's all you need to know. So because these two indices right here are both 2's, you can combine the stuff inside. And so what we write is we could rewrite this as a whole big long radical with 72 times 10, which is 720. X to the third times x is x to the fourth. And then y squared times y to the third is y to the fifth. Now this is a problem from Tuesday. So now I'm looking for, well, how can I split up 720? How can I split up x to the fourth? How can I split up y to the fifth? So 720 is, well, 72 and 10. 72 is 9 times 8. Okay. Let's see what else we can do here. 9 is 3 squared. 8 is 2 times 2 times 2. 10 is 2 times 5. Okay, so now let's see what we have here. If we check this out, we have a 2 squared and a 2 squared. So really this is a 4 times 4, which I can rewrite as a 4 squared. Okay, so now we have this 3 squared. We have a 4 squared, and a regular old 5. That was just the 720. I realize that that's a lot there. X to the fourth is x squared squared. Y to the fifth is y to the fourth square times y. And I can split this one up as y squared squared also. Now, I know this is like kind of a disaster of organization right now, but I'm going to clean it up now. So I have, if I rewrite my radical, I have 3 squared, 4 squared, 5. And then I have my x squared squared. And then I have my, let's do it in green, y squared squared. And then I have this y hanging out at the end. Okay. Pull everything out of the radical that matches the index, which is 2, by the way. So I got to have a 3 and a 4 and an x squared and a y squared times the square root of everything else that's not exponent 2. So 5y. Now we just need a little simplifying. We just have to say, well, 3 times 4 is 12. And again, let's think about, okay, do we need any restrictions on what x and y are? And this is a little bit weird here because we have to go back to the very beginning of the problem right up here. If you look at each of these individual pieces, here, I can't put in anything that's negative. X has to be greater than or equal to 0 here. Because otherwise, I'm going to get an error out because I'm going to have a negative number because a negative number cubed is still negative. So this part isn't defined unless x is positive or non-negative, I guess. It's not, could be 0. Same thing here. Y has to be greater than or equal to 0 here. Now, these domain restrictions, the thing that I'm talking about right now, is a little bit less important. What I really need you to be able to get to is this spot right here. This is really the key part of this, the sort of talking about what values you could put in or could get out of x and y. It's a little bit less important this year, but it is going to be something that you're going to be dealing with in pre-calc. So I'm just kind of trying to prep you a little bit for that too. Really, if you gave me this as your answer right here, I'd give you full points this year. Okay, that's fitting my expectation for what you can do on this learning target. Okay, so that's multiplying. Let's talk about dividing. Same idea, really. Basically, if you have something that looks like this, as long as the indices are the same, you can combine them into the same radical. So this is a cube root, this is a cube root, so you can combine them as the cube root of the whole fraction, which is 162y fifth to the fifth over 3y squared. Now we can use exponent rules to simplify the stuff inside the radical and then pull out whatever I can. Okay, by the way, 162 divided by 3 is 54. I just used my calculator because I'm lazy, but also like you can use it to be precise too, 54. Okay, y to the fifth over y to the second is y to the 5 minus 3. 5 minus 3 is 2. Just kidding, it's not 5 minus 3, it's 5 minus 2. Which is 5y cubed. Okay, so then I have a y cubed here. Let's see what else we can do here. Can we simplify this any further? Yeah, we can. First of all, I have this y to the third, so that's going to match my index. But also 54 has something in it that I can work with because 54 is 27 times 2. And I know that 27 is 3 times 3 times 3, or 3 cubed. Okay, now anything that matches, take it out. So I have a 3y on the outside, and then on the inside of the radical, I still have a 2. Okay, this is my answer. It's an odd radical, so I don't even have to think about the absolute value. The only time you have to think about the absolute value is when you have an even radical, even index radical. These are so fun, right? Okay. Rationalizing the denominator, I'm not going to lie. Rationalizing the denominator is like one of these old, like vestigial organs, like your appendix of math, where like you don't actually need it, but sometimes it just like flares up and You have to deal with it. That's a horrible analogy. I'm sorry. Okay. What I mean by rationalize the denominator is I want not a radical in the denominator of these two expressions. That means that I have to create something so that there isn't a radical there anymore. And so the strategy we have to use is we have to be like, okay, well, I have 2 there inside this radical. I'm looking for something that has an exponent that's a 2. So I'm going to multiply by something that gives me an exponent that's 2. But as soon as I did that, I just changed the value of the expression. So I have to compensate for that by putting something on the numerator also. Now, this right here is equal to 1 because it's the same thing divided by the same thing. So you're not changing the value at all. You're multiplying by 1. It's just a clever form of 1. Okay. Now we can multiply these two fractions and we can say, okay, well, 1 times root 2 is root 2. And then root 2 times root 2 is root 4. And I know that the square root of 4 is 2. There's my answer. I know. It's like, why would I ever want to do this? But I got rid of the radical in the denominator. I rationalized the denominator. We call it that because rational numbers are numbers that you can write as fractions, and 2 is a number that you could write as 2 over 1. So 2 is a rational number. Anything that has a radical is typically not a rational number. Okay, let's look at this other example here. This one, I have a cube root. And so I'm looking for something that has an exponent that's a 3 inside the radical on the bottom of the fraction. So I have to create that. So to get there, I need to multiply by the cube root of x because I have x squared. And if I multiply by another x, I'll have x to the 3rd. But I just changed the value here. So I need to compensate by changing the value of the top also the same way. So we're going to multiply by a clever form of 1 where the top and the bottom are the same. This is all equal to 1. So I didn't change the value at all, but now I have something in the bottom that I can get rid of the radical with. So I have 2 cube root of x squared because we have an x here and an x here, and then a y to the 4th over a cube root of x cubed here. I'm almost there. Okay, 2 cube roots of x squared y. I'm going to write cubed and then y because I'm going to end up having to simplify that anyway. And so I'm just kind of starting to prep that process a little bit. I also know that the cube root of x cubed is just x because the radical index and the exponent match. Okay, so now what do I have on the top? I can take this y to the 3rd out and rewrite it as 2y cube root of x squared y. And then on the bottom, I still have my x. There's my fully simplified expression. This is so fun. I'm not gonna lie to you. This is one of my least favorite units, and I think you can kind of tell why. It's just a lot of messing around with variables for kind of no apparent reason. But it is a set of skills that you need for future math classes, and that's why we introduce it in Algebra 2. So that's that. There's a chat. Oh, somebody raised a hand.
There's a
What's
hand.
up? Okay, hi.
Hi. So we're not doing the Desmos thing yet, right? Just to
We are
make
not
sure.
doing the Desmos thing yet.
Okay, I didn't know if it was like later in the slides and I just missed something.
It's coming, don't worry.
Okay.
Okay, I'm almost done though. Let's just do one of these examples. I have like a couple of them here. I know I just have one more. Oh, good. I was getting tired of talking. All right. One more to simplify and rationalize. First of all, is there any simplifying I need to do? No, because I know 5 is prime, so I can't pull anything out of that. I know x squared doesn't have a 3 in it, so that doesn't help. I have a 12, which I know is 4 times 3 or 2 times 2 times 3. So that's not going to work because there's no 3 exponents that are 3s there. There's no exponents that are 3s anywhere in here. So we just need to rationalize the denominator. But to get there, let's think about this a little bit. We have a 2 times 2 times 3 in the 12. So to get to exponents that are 3s, I need another 2 and I need 2 more 3s. So I need a cube root of, I need a 2, and then I said 2 more 3s, 3 times 3. I need another y because I have 2 of them already, but I need 3. So I'm going to put a y here. And then I want 3 z's, or z cubed, but I only have 1 of them. So I need 2 more. So I need a z squared here. I just changed the value of the denominator, so now I need to do the same thing to the top, the numerator. 2 times 3 times 3 times y times z squared. Okay. We're multiplying these two fractions. All right. What do we have here? We have the cube root of 5 times 2 times 3 times 3. That's all the numbers so far. I have an x squared from here. I have a y and a z squared from here. And on the bottom, I have cube root of, well, 2 times 2 times 2, because that's what we constructed here. And then we have 3 times 3 times 3, because that's what we constructed here. And then we have y cubed and then z cubed. Okay. So let's keep doing a little rewriting here. I have the cube root of 5 times 2 is 10, 3 times 3 is 9, 9 times 10 is 90. 90 x squared y z q squared. Okay, that's the whole top. The whole bottom is, okay, cube root of 2 cubed, 3 cubed, y cubed, z cubed. It's like a Dr. Seuss novel. Okay, so now the top is just the same because there's nothing for me to simplify out of the top because I've already seen, I've broken it apart. I've already seen there's no exponents that are 3s, so I can just keep copying the top. Okay, and the bottom is now 2 times 3 times y times z. I made a little mistake here. This should be a 3 right there. Okay. And then you could rewrite this 2 times 3 as 6. Okay, that's a whole lot of doing for a process that is very annoying. I recognize that. And here's the other thing. You can decide in your own head about which one of these is actually simpler to look at. Personally, I think the top one is a little easier to think about and look at and figure out, but there will be times, and maybe even later this year, that you're going to be expected to do a little rationalizing here and there. But the rationalizing you're going to do is a lot more like this and a lot less like this. Okay, I know I'm losing you. Here are some properties that we use so far today. Those are really the only two properties we've used today, besides the stuff that we've done before. You can multiply the radicals, you can divide the radicals, as long as the indices are the same, indexes are the same. Okay, Desmos time. you can either go to the assignment, or I'm going to put a link in the chat to click on. So here you go. Either way, I don't care how you click on it, but you need to get to this Desmos activity. I'll give you a second to do that. There are two things that are open right now, slides 1 and 2. Slide 1 is about like your happiness over the course of the year so far. So this is just like sketch a little graph, and then you can give me a little information about that. The next thing you need to do is, without using a calculator, because if you use a calculator, this ruins the whole thing. On slide 2, I want you to approximate where the square root of 2 ought to be on that number line. You can write yourself a little like, this is how I know, I think. Oh no, it's just a dot. You just have to put a dot on slide 2. I'm just going to give you like another 30 seconds to get slide 1 and slide 2 done. Okay, cool. I'm going to open up slide number 3. But while you look at, you're going to open up slide 3 and then look back at my overlay projection on Google Meet, okay? I need you to tell me something about what you notice and what you wonder about that picture of all of your responses laid on top of each other. Okay, just another 30 seconds to write a little something about what you notice, about what you wonder about. Thanks for the smiley face. I see a lot of people writing about how they see that most of the dots are between 1 and 2, which is great. A couple people are commenting about why the dots are kind of above the line for some people. Most people are saying between 1.3 and 1.5. One thing I wonder about is, why is there so much variation? Why is there such a difference between some people's choices? And I wonder what's up with that. Like, I wonder why we have sort of a hard time figuring out what the square root of 2 is. Remember, the square root of 2 is like, okay, what thing do you multiply by itself to get 2? 1 times 1 is 1, so the square root of 2 is not 1. 2 times 2 is 4, so the square root of 4 is, or square root of 2 is not 2. So it's got to be between 1 and 2. Okay, on slide 4, I'm giving you where the square root of 2 is on the number line. What I want you to do is I want you to put a dot where 2 times the square root of 2 is. And I'm leaving the overlay up on Meet also, so you can go back to the Meet and see the projection of where everybody's putting their little dots. The square root of 2 is about, I'm not going to say it yet. The square root of 2 is about 1.414-ish. You can check my work if you want. On slide 5, what do you notice? What do you wonder about the overlay that I have on the screen right now? And it seems like there's a little bit more agreement this time that the dot should be somewhere in this range. And so I think it's one thing that I notice is that it's interesting that like now that we have a little bit of data about what the square root of 2 is, where that is, that black dot on the screen, it's interesting to me that we have a little bit more precision, a little bit better ability to be precise with this now that we have a little bit of frame of reference. For a moment here, just think about like, what is the strategy that you're using to figure out where you're putting the square root, 2 times the square root of 2? Why does that work? Why does it work to like use the piece of information that I gave you to get your answer? So just think about that in your head. I know that there's not really somewhere to write that, but like, it's kind of an interesting thinking question. All right, cool. I'm gonna skip the next one just for time, but come back to it if you want later after class. It's kind of an interesting one. I want you to open up slide 7. And yours is gonna look like this. I want you, this is not what I wanted it to look like. That's okay. Yours is gonna look like this. What I want you to do is I want you to simplify these two radicals multiplied together, square root of 50 times the square root of 20. I want you to think back to those properties that we talked about at the beginning of class where you can multiply the stuff under the radicals as long as the index is the same. I want you to type in your steps and then your final answer. How do you get there? So I might start by writing square root of, well, 50 times 20 is 1,000. Okay. Desmos is going to give you a little decimal answer here, but I want you to go further. How can you simplify the square root of 1,000 now? I might write something like this. I can multiply the stuff, and maybe I would use the fancy the word, which is radicand. I can multiply those two radicands because the indices is the plural, indices are the same. So that's something that I could write for the first step there. Then I might split up my square root of 1,000 into two things multiplied by each other, and then see how I can split that up further. See if I can find any squares and then pull them out of the radical. Okay. I know that 1,000 is 10 times 100. And I know that 100 is 10 times 10, or 10 squared, like that. So then I might be able to write, well, this is 10 square roots of 10. By the way, there is a keyboard right here, so you can type in your square roots. And if you need a cube root or whatever, you can use this button way at the bottom of this keyboard. So that's that there. You can also do a little typing. There's some typing shortcuts in this too, but. Sweet. Good. So I would write, I know that 100 is 10 squared. So I can rewrite, or I can pull that out of the radical. This would be some of the stuff that I'm expecting you to be able to write to explain what's happening here. So that's what I'm looking for on these. This is a little bit of a hint because you're going to see that on Monday, I'm going to post your assessment for this learning target, and your assessment is going to be on a Desmos activity that looks exactly like this. So just be prepared that I'm going to be looking for you to show your steps out on Desmos like this. On slide 8 is really exactly what you're going to be looking at on the assessment. There's going to be this little table. So I'm going to give you instructions on the left side of the screen. I'm going to show you, okay, this is where you're going to type your steps. And then you're going to write a little like half sentence, just explaining what each step was that you did. So if you want to switch back to the Google Meet to watch me do slide 8, that's great. And then you can try slide 9. Here's what I'm going to do. I have x to the 4th, y to the 10th. I'm just going to copy that in because I want to have it. So x to the 4th on the top, y to the 10th on the bottom. Explain what you did, explain why you did what you did. I just would write copied question. Okay, on the next line now, this is going to open up another line where you can kind of put in your next step. I'm going to rewrite square root of, okay, I'm not going to write x to the 4th, I'm going to write x squared, and then put that in parentheses. And then I'm going to write that squared also, because now I have an exponent to an exponent, power to a power, you can multiply those exponents. Same thing here, y to the 5th squared. Now I would write power to power, multiply exponents. For example, this would be my explanation for why I'm doing the step that I'm doing here. This is what I'm really looking for you to do, because this is telling me, do you understand what's happening in this unit? Or are you copying it off of PhotoMath? Just saying. No? Okay. Yeah, so we have, this is an exponent property that we talked about on Monday. Now I can pull out that x squared and that y to the 5th, x squared, and then divide by y to the 5th. Now I would say index matches the exponent. So I can pull out the x squared and the y to the 5th. My final answer, I'm fine with you leaving it here. If you're fancy, you can think about that absolute value. And the thing that you're going to notice is you need the absolute value around the y to the 5th, because you could put in a negative number for y and get an answer out at the very beginning. But if you put in a negative number for y at the end, it would be a negative answer. And so we want to get rid of that. So it has to be x to the 2nd over absolute value y to the 5th. There it is. I might write something like that. Hey, you can put a question in the bottom of this box right here. No one else is going to see these questions, but this is just going to give me a little opportunity for me to look at your feedback. What questions do you have? What do you want to ask me? I'll look at those after class, so I won't be able to get to those right now, but I will look at them after class, and then I might send you a little message. All right, I'm opening up slide number 9 so that you can try this process. I'll leave my slide 8 up on this screen so that you can flip back and forth. But on slide 9, I want you to try to do this simplification process for yourself. A little practice for your assessment on Monday. I'm seeing a couple of questions just about like, well, what if I'm like not that great at like thinking about the factors of a big number like 224 or something like that. That's why your calculator is there for you. Like I happen to remember those things, but that's mostly because I teach high school math. Like if I was not a high school math teacher, I wouldn't have those abilities. And so I'm not expecting you to get everything perfect and be really accurate with your mental math all the time. That's why I have a calculator sitting on my desk right here. Like I use a calculator all the time just to make sure that I'm doing things right. Um, and I would encourage you to use your calculator too. Don't be afraid of it. It's not a crutch, it's a tool. Okay, so that's that. How many steps should be shown at the minimum? There isn't a hard and fast rule. What I'm really looking for is a complete answer. And so if you combine a couple of steps, but you can explain that you combine those steps, I'm good. As long as I can see what you're doing and why you're doing what you're doing, I'm happy. Good questions, I appreciate them. Okay, how do we break up this 270? And yeah, you can simplify the variables for the in the first step. Yes, that's true. Like for this one, it has a y to the 5th over a y squared. I could simplify that into a y to the 3rd on the top of the fraction first, and then pull something out from there. I might start by doing that with the numbers too, because there's a 270 and a 15. And so I would probably start by doing 270 divided by 15 first, and I'd get 18. So if I open up mine, I would maybe start by I would write my whole answer, but then my next thing that I would write is I would write 18, and then I don't have any x's to cancel out, so I have x to the 4th. I have a y to the 3rd, and then a z to the 6th. Okay, so what I did was I took the numerator and denominator and used what I know about exponent properties to simplify the fraction first and then pull stuff out of the radical rather than doing it the opposite order. So either set of steps works just fine. Great question. It's okay if you're confused. I'm seeing people who are writing, I'm just confused, I need help with this. Don't worry, at the end of this, you're going to have an opportunity to tell me what you're confused about, and then we can connect later. So you can either stay on the call at the end of the lesson if you have time, and if you don't have time, that's okay. We can meet another time. You can schedule a help meet with me. All right, great. Let's do number 10. Opening it up, you can go to slide 10. This is the same basic question, except there's multiple choice answers here. The options on this are a little bit weird. There are at least two expressions that actually have the same value on this one, on slide 10. Make sure your answer is all the way simplified. I'm challenging you to think, can you actually simplify that square root of 18? I agree with you that there should be a square root of 18 there, but a lot of you are saying, oh, I should just stop once I do the combining. But check this out. There's something to simplify in that square root of 18. A lot of you got to that first step where you were like, okay, it was -8 and then square root of 18. So that's great. That's awesome. You combine the two radicals. That's excellent. However, 18 is 9 times 2. 9 times 2. And so now you can also check your work on this one. This is actually really exciting. On Desmos, it gives you an answer. It tells you what the value of what you put in is. So you can make sure that you're making the right steps here. Okay. So I split up 18 as 9 times 2. 9 is 3 squared. So I have -8 square root of 3 squared times 2. 9 is 3 squared. Okay. Then you can take out that 3. And so now you have -8 times 3 square root of 2. So I'm just writing a quick description, right? Just tell me why you chose to do what you chose to do. And then, yeah, your answer is going to be B, which is -24 square root of 2. Simplify 8 times 3. All right, I have more, and I'm going to open up the rest. What I want you to do is I want you to choose as many as you can in the next 10 minutes. So your job between now and the end of class is to do as many of these ones as you can on slides 11, 12, 13, 14. After you do that, so don't go to slide 15 yet. After you do that, then go to slide 15 where it's going to ask you, what are the things that you need help with? Do you remember two-column proofs from last year? It's kind of like that. Some really good stuff happening on slide 11, so thank you. Okay, where do I start on slide 11? Well, let's look at this. Can I simplify anything with the p's? Because there's a p on the top and there's a p on the bottom. So I know I'm going to have a square root and I know I'm going to have a fraction. So let's just keep those two things there. But p to the 7th over p to the 3rd, you can subtract those exponents. So it's 7 minus 3 is 4. So my exponent on the top is going to be a p to the 4th. So that's my first thing that I'm going to do. I'm going to just get rid of those p's on the bottom, do what I can to simplify that part. Then I have to deal with the 8/32. And I know that 8 is 2 times 2 times 2. 32 is 8 times 4. So if I just think about, okay, I have 8 on the top and then I have 8 times 4 on the bottom. The 8s divide to 1. And so now what I have left is I just have a 4 on the bottom. So I would write 8 divided by 8 times 4, and maybe group these denominators so that I'm really clear about it. I would write that's equal to 4. So that's why I have what I have on the bottom. Sorry, 1 over 4. So that's the bottom. On the top, I have p to the 7th divided by p to the 3rd. And I know that's p to the 7 minus 3 from proper exponent properties on Monday. And now this is telling me, okay, well then this is p to the 4th. Then I would start simplifying from there. So I would think about how can I get exponents that are to the 2's so that I can start pulling stuff out of the square root. One piece of feedback that I have for you is that you need to be really careful of where the square root is. So if the square root is around the whole thing, make sure your square root symbol goes around the whole fraction like mine, instead of the square root just being on the top, for example. Okay. I'm going to call a 2-minute warning on practicing these problems. If you're like, oh man, this is just not going good, let's talk later. Okay. Let's make this happen because I know that you can get there. And if it's just we're going too fast, then we just need to slow down and we need to work together individually. So this is the problem with online school, is that it's really hard for us to work individually. So that's why we have to kind of seek out those additional opportunities. Okay. Okay, I would like you to go to slide 15 now. Slide 15 is asking you a bunch of things that I'm asking you if you need help with, okay? So, for example, if you need help with what we did on Tuesday and you're just like, I don't even understand that part, check that box because that tells me something specific that you need help with. If you're like, okay, most of the stuff on Tuesday was pretty good, but the next 3 things that we did today were kind of confusing, then check those boxes. Tell me which parts of it you need help with. There are also some other kind of check boxes here. You need help understanding how grades and assignments are going to work in this class. You need help with other math questions that are not listed in this checkbox. You have school issues that you need to talk to somebody about. You can check that box. If you have other life stuff going on, you can check that box. If you're basically good to go, then you can check that box. Okay. Hold on for a minute because I have like one more thing to say. And I want you to just keep the Desmos window open because I want to go back to the Google Meet. So come back to the Google Meet for just 30 seconds and then I'll have you finish up on slide 15. Here are the things that we've done today. We simplified expressions that have multiplication and division. We rationalized denominators. Those are the 3 big things we did. Okay. The things you need to do today are finish the practice problems that are on Desmos. So you can keep the Desmos screen open and just finish those problems. So I'm going to stop controlling where you are and you can just flow back and forth and do the problems that I'm asking you to finish, okay? In the chat, yes, you want an answer key to all these problems, or no, you do not want an answer key to all of these problems. Please put something in the chat for that. No shame either way, I just need to know, because I'll make one if you want one. The last thing you need to do is you need to complete the mastery check that's linked on Google Classroom. So 3 things: finish the practice problems, tell me if you want a key, finish the mastery check. That's all. Okay. I will make an answer key and I will post it probably for tomorrow's lesson. So you'll have it at least. Okay, I'm going to stop recording. That's all I have time for.